This is the video of imaginary number review. Here's the warm-up. So if I want to subtract these, it's going to be 4 minus 3i minus 5 plus 6i, and then just combine like terms. 4 minus 5 is negative 1, minus 3i plus 6i is plus 3i. This next one, just solve, we want to take the square root of both sides. So plus or minus square root of negative 64. I get negative 1. Pull your eye out. And then take the square root of 64. So we know the square root of 64 is 8, so plus or minus 8i. Slide 2. It says you can do completing the square if this is a 1. That's the only way he taught you. In this one, I'm going to use the quadratic formula. So this first one, subtract 5, and complete the square. So I'm going to add 4 to both sides. Factor to the left. And take the square root of both sides. The square root of negative 1 is I. Plus or minus I. Last thing to do is add 2 to both sides. So x is 2 plus or minus I. This one here, use the quadratic formula. So the opposite of negative 10 is positive 10. So 10 plus or minus 10 squared would be 100. Minus 4 times 8 times 7. This looks like a similar problem from the last activity. I think this is the same problem actually, but go ahead and finish it. Uh, 32 times 7, 224. 100 minus 224 would be 124. Pull your I out, so negative 124 is I square root 124. I'm at 16. I'm going to stop there. This one, subtract 81 from both sides. And take the square root. Subtract 1. And 81 is a perfect square, so you can take the square root. And I guess it's the same problem as we done on the other slide, but we'll go ahead and do it. Using the quadratic formula, the opposite of 3, negative 3. 3 squared is 9, minus 4 times 3 times 1. And then 3 times 2 is 6. Uh, 9 minus 12 would be negative 3. And finally, pull an I out of the radical here. This is the same as a problem on the previous video. This one here, I'm going to complete the square. So, do negative 2. By 1. Negative 1. 1 squared is 1. So add 1 to both sides. And take the square root of both sides. 1 plus or minus I square root of 2. And then this last one was also on the last activity. So here I'm going to use the quadratic because there's no x term, so I can use the square root here. So first subtract 3 from both sides and divide by 2. And finally take the square root of both sides. And pull an I out of the radical. So some of these problems are the same as the last activity, and the reason why is because the modified schedule on Wednesday didn't get through much with the Wednesday classes. And then slide 4. I'm going to use the quadratic formula here. Opposite of 5, -5. 5 squared is 25. 4 times 1 times 11. Divided by, whoops, put parentheses here, and then I'm going to put everything in the numerator. -5 minus 44 is 9. -9. Pull an I out and take the square root of 9. It would be plus or minus 3i. Oh. So -5 plus or minus 3i divided by 2. The second one, get all the terms on one side. And then use the quadratic formula. The opposite of -9 is +9. Square root 9 squared, 81, minus 4 times 8 times 7. And this is probably one of the ones that's the same. It's a lax activity, and then divided by 16. 32 times 7, 24. And it's 143. So 9 plus or minus I square root of 143 over 16. This one here, you can do the square root. Same as one of the other problems on the previous activity. Again, so 2x squared, add 2 to both sides, and divide by 2. And take the square root. Pull an I out. And then this one here, since this is a 1, I'm going to complete the square. So first, subtract 68. 2 divided by 2 is 1. 1 squared. Add 1 to both sides. Back to the left. And then take the square root. It should be plus or minus here. One I out here. You get x equal -1 plus or minus I squared of 67. This is the same exit ticket as the previous activity, so I'm going to grade it here. I made the other one 0 because it changed some of the slides here. Let's take a look at the challenge problems here. So it says without solving, how many solutions will this have? So all these are the same. So you can do b squared minus 4ac, so 4 squared minus 4 is 1 times 3. So 16 minus 12 equals 4. Two. And then this one, 4 times 3 times negative 17. Four plus whatever 12 times 17 is. So 204. The real solutions there. Here you have negative 2 squared. Four times 3 times 17. So 4 minus 204 this has two complex solutions. And the last one, 4 squared minus 4 times 1 times 4. Minus 16 equals 0.